I'm just going to give a bit of a overview of only a really a postage size, stamp size part of the Cobar story that Joel has covered a lot of in that last talk. It's been a while since anyone's given a presentation on Federation due to COVID and other things, but Adam McKinnon is one of the co-authors. He's moved on to magmatic now to different challenges. And myself and Peter Smith have been largely running the exploration at Federation for the last 3 years, pretty much since discovery. So the deposit was discovered only about 3 years ago, and we'll go through that. Now, I'm not going to be making too many financial disclosures or predictions in this, but any forward-looking statements I might make, don't use those solely to guide any investment opportunities. And as I just mentioned, there's been a number of people work on the deposit over the years, and I'd like to acknowledge their persistence and from the discovery period, which was firstly with YTC Resources identifying geochemistry, geochemical anomalies and starting the drilling process, through to the Aurelia phase, which was, and some of the people on that list are present here, and the story down there just keeps giving and giving. So, but you do need to be persistent, and that comes out in the discovery history at Federation. Now, where it's located, and it's been a dot on a few of the maps that Joel was showing, it's about 15 kilometres south of the village of Nymagee and about 10 kilometres south-southwest of the operating Hera mine. And it's a structurally controlled deposit. It's hosted in under the mud rocks and fine-grained sandstones of the amphitheatre group, near contact with an underlying more quartz-lithic feldspathic basement-derived Miranda group sequence. It's quite different to the other deposits with regard to its orientation in that eastern basin margin along near the Rookery Fault. It's a bit offset from the Rookery. It's about 6 kilometres west of the mapped trace of the Rookery Fault, and its degree of strain is noticeably lower than at some of the deposits on that structure, like Nymagee and Hera. And that might be, and it's probably partly related to the older Silurian Erimerian granite to the south, which has acted as a structural buttress. And just credit to the Geological Survey for that map there, is the seamless geology. So the history of Federation goes back to the YTC days, which Coops and others were looking at any sort of decent areas of geochemistry that they could find. Federation occurs on a very low, nondescript topographic high, just south of Hera, and there is an outcropping deposit at Dominion about 1 kilometre away, which has received exploration from time to time and has kept the ball rolling in that district for the discovery of Federation to finally happen. But lead and gold geochemistry was targeted back in it was 2011 or sometime around there, with some shallow RC holes, but didn't really yield much in the way of lead zinc, although quite anomalous, obviously 1 to 2% combined. But the mineralisation isn't exposed. It's only really subcrop in that area, enough residual profile but to get a geochemical anomaly. The most near surface part of the as we found, the deposit is completely obscured by a paleo valley and ferrocreted alluvium. So the geochemical signature, if any, from that is completely muted. So the discovery really goes back to 2019, the more recent discovery, when an IP survey, pole dipole IP survey, was done over the district, including the Dominion prospect and environs, and it defined some very strong chargeability anomalies. And the thing about Federation was that it also had a coincident conductive anomaly and that was targeted by the revised renewed drilling exploration back in 2019, which ended up discovering the deeper western part of the deposit. And we sort of spent a bit of time drilling that area out, and it wasn't really, it was a little bit hit and miss at one stage, but then a step out to the northeast with RC jagged some high lead, zinc, gold material, which basically became the northeast lens, which we'll see when we look at a long section in a couple of slides. And that really got things going. That was extending to about 60 metres from surface and had some massive sulphides, extremely high grades. And it's pretty much been my world for the last 2 and a bit years. I wasn't around for the discovery. I came just after, which was good timing, I think. But since then, we've drilled pretty much almost 130 kilometres of mostly diamond with RC, and we've been focused primarily on getting a resource ASAP, given that the Hera mine is coming to the end of its life. And at present, we've got the published resource of just a bit over 5 million tonnes at almost 15% combined lead and zinc and almost a gram of gold with accessory copper and silver. And as you'll see in the next slide, we've been the more recent drilling is largely outside that, well, partly outside that original resource. So we're looking, it's looking encouraging anyway when a new resource estimate is released later this year as part of the feasibility study that's ongoing at the moment. And the deposit, we haven't really had the time to step out. We've been focused mostly on just infill drilling this beast to get the resource categorisation up, and hence the deposit is pretty much open in every direction along strike and down dip. In long section, the deposit's made up of pretty much a subvertical sheet of breccia style mineralisation with very high grade plunging shoots of massive sulphides, which I've just indicated there in the orange. And those massive sulphide shoots also contain more restricted, very high grade gold phases within them. We get quite a bit of coarse grained visible gold throughout the massive sulphides, and probably a little bit more convenient than Hera that the gold tends to be pretty much in the massive sulphides. We haven't found any high grade gold really outside the lead zinc ore. So grade control wise, and hopefully it'll be a bit of an easier beast than Hera. So they're the three main lenses: northeast lens, western lens, and the HP lens. They're particularly probably they will be made up of more complex and probably multiple lenses within those. We haven't drilled out to the required resolution yet. It's mainly been a resource drill out to about 25 metre spacing, and the resources at this stage goes down just a bit over 500 metres from surface, starting at about 50, 60 metres below. There's a small oxide component to the resource, but not a major supergene type deposit over. Now, just a bit of it is a epigenetic structurally controlled deposit, but there is some sort of indication that the local stratigraphy has been important in the makeup of the deposit, and in largely producing rheology contrasts that are exploited during later deformation and brecciation events. On the left-hand side there, the upper part of the deposit sequence is pretty much mud rocks with a variable calcareous siltstone, fine-grained sandstone, typically bioturbated. You get little fossil fragments, probably sponges or stromatoporoids, and fragments of other faunas. And underneath that, and interfingering with that calcareous mud rock sequence, is a more siliciclastic bedded turbidite, which we correlate with the upper part of the Maramba group. And it's inferred that changing bulk composition and interfingering is important in the exerting some sort of control on the mineralisation and making it a favourable position and producing the rheology contrasts that really need to be exploited by those during brecciation events and mineralisation. So there's a progressive series of events that have contributed to what Federation looks like, starting very early in the history of the basin, and even very close to deposition. And we'll go through some evidence for these different events in the coming slides, but it's potentially the plumbing for the system was set up very early, including early faulting and sedimentary deformation when the sediments weren't consolidated even, dewatering pathways, and then having been exploited by later tectonic events. And we'll see some slides later on that show a bit of that aspect. But another factor is there was a major stratiform alteration early in the system before significant mineralisation, and that seemed to pick out some of these more porous quartzolithic sandstone units, and not the mud rocks. The mud rocks tend to be quite a chloritic type composition, whereas a major silica pyrrhotite alteration occurred in the siliciclastic units. Early on as well, there's an early folding event with a pervasive axial planar cleavage and northeast-southwest striking cleavage, which is the same orientation as some of the earlier soft sediment faulting, which would probably suggest that the earlier growth faults or transverse faults have been reactivated during that early folding. Following the development of open anticlines during that folding event, a phase of brecciation and silica flooding, which progressed on to the influx of sulphides into the deposit. And the later overprint's quite muted by any standard, with just pretty much shears and a possible S2 foliation localised in chlorite altered domains, and both bedding parallel and cleavage parallel orientations have been identified, and there was minor brittle reactivation as the last event, which was accompanied by quartz veining. So just that same slide in a different way, there's a continuity of a progression of events which have formed the mineralisation. And so evidence for the early structures, you can sort of get a feel for these small folds that you get throughout the laminated sequence. They're not accompanied by any ductile fabric or any axial planar foliation. They're interpreted as sedimentary slumping, and there's you get little dish and pillar structures which are evidence of fluids being escaping through pathways through the fine grained sediments, and that plane of weakness was probably exploited during the later folding and cleavage formation. So now some of the alteration that you see is this stratiform silica pyrrhotite, which you basically is just a really spotty pyrrhotite, bedding controlled, possibly replacing carbonate in the original units, but then that has been deformed and a strong cleavage has been formed, and it's predominantly that pyrrhotite that defines that. And in that slide to the top right, even some of these pathways are, with the sulphide in them, look like they are original soft sediment structures that have been exploited by space cleavage, and in that case it's actually been mineralised during later lead zinc introduction. And in cross section there's a number of these silica pyrrhotite horizons right through the deposit. There's only been 2 of those shown in that diagram, but they pretty much are stratiform. They follow particular units, and the deposits in cross section, which we'll go into a bit later, is localised within where you see those units folded into gentle parasitic anticlines. And it's despite all the pyrrhotite in the alteration, the deposit itself, the sulphide mineralogy, is very low in pyrrhotite. So there's a potential that the sulphur from some of this alteration has been scavenged by the deposit to form the lead zinc mineralisation. So the earliest phases we see of brecciation and mineralisation includes some quite striking epithermal type banded veining and infill, only really preserved in rare spots where it hasn't been overprinted by later more massive sulphide phases. And that silica phase has been, as you can see in the slides, been overprinted by subsequent veining and also breccia phases. So that, I suppose, progresses into the deposit of where we start to see the massive sulphides that have focused in those shoots. And in that slide, there's an example of the massive sulphide to breccia transition at the end of at the edge of a lode intercept, and there's also a milled breccia there of silicified siltstone surrounded by a chlorite a matrix with sulphides, and that's a proximal association with a distinctive black chlorite, magnesium-rich chlorite alteration assemblage. And the real meat of the deposit is these massive sulphide shoots that we've identified at least three main ones, the three lenses, which are plunging very steeply to the east, and they can have up to 90% sulphide overall. Some of the grades are looking at 60% plus combined lead zinc in the centres of these, very little gang, and free gold. Quite in more restricted shoots, but still within the massive sulphides. And just looking at the different lenses are very similar in the mineralogy, and there's some of the indicative grades from the high grade parts are listed on that slide, but it's generally a low iron sphalerite dominant, a brown to honey coloured. And galena, chalcopyrite with only minor pyrrhotites. Quite a simple mineralogy, and that indications should be encouraging for metallurgy as part of the feasibility work. So just looking at things from a slightly different way, I suppose, like going from the mineralisation outwards into the country locks. From massive sulphide, we progress out through a more complex breccia with more entrained, altered wall rock to the right there, with variably deformed sulphide banding in places. And the real district scale alteration is really a replacement of pyrrhotite in the host rocks by sphalerite and galena. You can see in the bottom left there, there's bedding control pyrrhotite in there, replaced by a brown sphalerite with some black chlorite as well in that rock, and that's sort of the background Federation style alteration. And you start seeing about 1,000 ppm zinc and lead where you start getting that, and that's a way of finding, knowing that you're in the system, and that you're not necessarily going to be very far from an ore body. That alteration probably extends about 100 metres, both into the hanging wall and footwall of that subvertical sheet of mineralisation. And just as some of the late faulting is reflected just by a brittle, in places, brecciation of mineralisation and other wall rocks, commonly along bedding parallel contacts, adjacent to some of the silica pyrrhotite altered beds. But there are shear zones within the mineralisation where we do get the chlorite altered to a crystalline talc, but that's quite a unusual feature. And there's a lot of quartz veining accompanying that brittle phase of mineralisation. So just moving on from what the rocks look like, just reiterating the structural makeup. Very gentle folding, cleavage localising the mineralisation, forming a plane of weakness and for later breakage. Where that bedding rolls over is where the deposits are, and there's probably some late thrust deformation, but not not a lot of throw. And the next slide we'll look at it in cross section, just a conceptual potential structural history. So I suppose we view the top of that figure. It's all, you'll just have to excuse my cartoon, but we're looking at an early sort of gentle compression verging towards the basin margin, which in this place is to the southeast, and we go into more of a wrench type system as the basin to the north starts inverting to a greater degree, producing a dextral sense of shear to open up these breccia zones in the pre-existing planes of weakness in the anticline closures. And after that, really, you were just looking at reactivation of those particular faults, either ductilely or brittly. So just a final slide, or a couple of slides. There's Federation in summary. It's got some things common with the other Cobar type deposits. It's also got some differences. It is related to a basin margin fault system. It's hosted by Cobar Basin sediments at a similar stratigraphic level to Hera and Imagi. There's some early folding and anticlinal traps being developed. Mineralisation is localised where there are comedonate contrasts and differences in fold style and degree of fracturing. And the deposit is made up of steeply plunging high-grade shoots. And some of the differences, but it's wholly oblique to all the other eastern basin margin structures and deposits. There's preserved early history there, so it's probably a good laboratory to look at some of these, possibly these earlier events. It hasn't been strongly overprinted, and it only has a weak deformation overprint, which once again allows some of those earlier features to be preserved. So just from our point of view, how we're going to go and look for more of these, it looks like trying to identify early structures through dewatering and slump folding and is going to be important. Away from the faults might be a bit better, given that the later overprint is not an issue, and this deposit is pretty much sitting blind, covered by 50 metres, and there's less inversion, less overprint. Alteration systems are preserved, so you can define the system, and then within that, look at your look where your deposit is, and it's there's looking at rheology contrasts. You don't always sit in the Cobar area that might be defined by rhyolite versus sediment, whereas in this case it's a stratiform alteration which is providing those that particular aspect. And we've used IP surveying to great success to identify the pyrrhotite system, not fingerprint the mineralisation, and then as far as you can get good residual geochemistry to locate the cherry within the alteration system. That's important. And this has drawn on some quite a bit of work over time. Hopefully we get a bit of time to think about things a bit more. And just where it's at the moment, we've just fired the first lift of the box cut to access Federation Underground. So that's all going. Thank you.